Okay, so in the beginning of time, what was space? What is space? Okay, so space was one gigantic ice cube. In the ice cube, there was magnets distributed all into this ice cube. Now, this ice cube, it stays frozen because we're literally inside of an ice box. But when you introduce magnetism, it turns in when you take magnets and you put it in ice like that, it inducts electricity through thermodynamics, but electromagnetism. In electromagnetism, you have magnets that are orbiting each other that don't need anything visible or you can touch in the middle of them. Now, when the Big Bang happened, the reason that you see all of the planets in planetary alignment is because that's what was all left after the explosion. Because when you take magnets and they collapse down on each other, they don't just collapse down on each other. They also are bringing metals with them, and those metals are scraping fire. That's why you see hydrogen and all this other stuff forming up inside these stars, is because magnets attracted iron into them or certain metals to them, because that's what would have happened in ice. Now, it would have taken a long time for this to happen, but we would find structures just floating there. Those structures are where the ice or the where whatever was left over from the initial explosion. And after that, it literally had magnets floating everywhere in space. But not just any space. This means that the farthest we can look out to space, we're gonna see a wall of ice. I guarantee you, somewhere along the line, we're gonna see a wall of ice. And that's probably what all that dark matter is that you're talking about, that we can't see and can't find. That's because the initial explosion was so big that it just kept going. The heat melted all that ice as far as it could go, and probably was infinite because it's water. Water is notoriously known for being in plentiful form together and making in that initial explosion from the magnets collapsing down on each other and then magnetically aligning with each other, that would have inducted electricity. That electricity, most people are like, well, we don't find electricity in space. Yeah, I know. We're standing right now in an atmosphere. Look, we're standing on a planet right now where we know that there's a lot of electricity up there in that atmosphere, but we're not feeling it and not seeing it. Electricity is known for being very elusive in science like that. Here's another one. People's like, well, why does it feel like nothing's moving in space and everything like that? Because we're inside the cylinder of it. Look, when you're falling, infinitely falling, you're not gonna feel anything if you're matter of fact, you ever see dust? You ever see them old TVs? You know the dust that collects up on the bulb? Okay? That's what we're feeling that's what we're feeling. It's inductivity. Matter of fact, here's another one. We literally are black holes. Okay, look, we are black holes. We absorb light through our eyes. There's no sound in space, right? Can't really hear anything like that right there, right? We absorb sound. All of that in there is a fucking black hole. When you look up in outer space and you see a black hole, that's the mind. It could be the eye, it could be the ear, whatever it is. But if you keep zooming out, you'll start to see the face of whatever is up there that's looking back down at Earth. If it can find Earth. I don't know how it's going to find Earth. But because most of what you see up there is huge. Another one is, when you look down at the Earth, what you don't realize is that this is an eyeball. I'm going to just show you something on. this these plants, they collect sunlight just like our eyes. See? That sunlight goes into the roots. Okay? Those roots are connected to the soil. If electricity goes into that, in which there's a plant I showed you before, this is an eyeball we're standing on. It can see us. Or maybe it can't. Maybe we're its imagination or its. Let's just start from right there first of how space got here in the first place. It must be like it just popped into existence from nothing. Well, we have enough data to know that if everything was black in the first beginning, like completely darkness, that means that there was no light. And if there was no light, it must have been really, really cold. Because if there ain't no light, it's usually cold. If you go into the ocean, the further you go down, the more and more colder it's gonna get. It's not gonna get no hotter. Unless you find some caldera that's boiling up lava and magma somewhere underneath, the ocean somewhere. But it's just gonna get colder. Another one is, once you introduce a heat source to it, what happens? You start getting warm fronts and cold fronts and severe weather, and then that's probably where we get bioluminescence. Okay? Bioluminescence lights up just like electricity too. And if you look up in outer space, that's probably what happened. Everything that's redshifted, it might not just be stars. That might be bioluminescence. I'll come back and I'll put some more on here in a second. But that was a 7-minute video of me talking about scientific stuff that just thinking out.